All right, we are live now, and let me actually, can I grab a link? View on YouTube. Oh no, am I gonna get some background? All right, we're all good. How's it going, Dove?
It's going good. How is it going for you, Dan?
It's going pretty good. It's been a busy week, which is always good after lunch. If you are busy, but you're not fixing a bunch of issues, you're building on what you delivered. Also, it looks like Chris is here. We'll pull him in. And so, yeah, I thought it was a pretty fun week, and now we're culminating it with our quarterly hack day today. So, yeah, overall, lots of fun.
Hello,
Dan.
Chris.
I think you're on the wrong mic. Just so we're.
Let's see here. Not according to StreamYard.
Okay. Well, I showed up late, so maybe I'm wrong.
Does it sound bad?
It's okay.
Well, what is it? What does it sound like?
It sounds like it's in the middle of your room.
Interesting.
So, yeah.
Well, let's see here.
How does mine?
While Dan's
sound?
fixing that, Dylan, what are you working on there? What do you got going on with your? You doing your plant thing?
It's today is Hack Day, Goliath. I am pivoting a previous hack project I did to, instead of being focused on identifying birds, it's now focused on identifying health issues with plants. I don't know if you can see it, but right there is a little ArduCam camera. And this is like a miniature greenhouse with a bunch of plants in it, and the camera's facing down. So the theory is I can stream images of plants through Golioth Pipelines as binary data, which previously, in a couple months ago, Hackathon, it was being sent as like little JSON objects with a byte array, but now we can stream binary chunks. And then on the other end, I'm going to try to do some kind of AI analysis to tell if my plant is sick.
Nice.
What does a plant mean? How do you because some plants just are a little more relaxed than others. What are the telltale signs?
Yellowing leaves
is it like
probably
group?
Like that. I don't know exactly how to do this because I am not an expert in developing AI models in any way, but I expect there could be a couple different ones. There's like yellowing leaves, detect if leaf is yellow. There's like browning leaves. One problem I had with
it's too late.
The
leaf is gone.
Is the leaf like got real mushy and like started to disintegrate? That was some kind of like fungus situation potentially, but perhaps we could just train a model of a healthy plant, and then if it doesn't look like that, then it notifies you.
Nice.
Hot dog versus not hot dog, huh?
Yeah. Right. But you can tell all these plants are wildly different, so I feel like you might need a model like per plant or something.
So, do you already have a pipeline set up for this?
I do, but the current pipeline is based upon constraints of the old output streams. So it's still sending the data as JSON with a binary array of chunks of the images. Mike, who's on our DevRel team, is helping to do the firmware side to change it to send binary data. But what's really cool is I can have two output streams set up and handle like the legacy implementation and the new implementation and kind of test them at the same time.
That is very cool. What are you working on, Chris? Are you muted?
I'm working on an AI unmute button. I'm just kidding. That would be too much power for one program to have. We've been working on our Aludel Elixir platform, which is our reference design platform NRF9160. It's got ESP32, and our DevRel contractor just got the Wi-Fi SSID MAC lookup working out of that. So basically, in Zephyr, you can do this with a raw AT command, but in Zephyr, there's also the modem subsystem that talks to the ESP AT binary that's on there. And he was able to reformat it so that we can pull SSIDs. So I actually just got back to my house. I've been driving around. I have to look at the data. But basically, to get ad hoc location data like latitude and longitude, you can utilize things like the cell towers, which are very inaccurate. You can utilize things like GPS, which are quite accurate. And you can use things like which Wi-Fi SSIDs you are currently seeing, and then you can send those out to a database. And so in conjunction with Chris, who wrote the device side code, and in conjunction with Jonathan, our CEO, who showed in our last week's stream how to use a thing called N8N using webhooks, got that all set up. And I can show it here in a second, but maybe that's enough for a first pass.
Cool.
So data out, data back in.
Yeah. So we did kind of like a demo related to this with the cell towers, like you said, that was very approximate in terms of location. I was in that case, there was like some open source data that we were able to use to do that, which was, nice. But once again, like there were cases in which it connected to a cell tower that wasn't in the data set, and things are changing and that sort of thing. For the Wi-Fi SSIDs, how is the location data sourced for those?
All of that is using a here.com API. And so there is actually a joint, now that my screen's up, I can kind of show it.
Cool.
But there is a joint Wi-Fi, what do they call it? Find position with cell and WLAN. Let me share my screen real quick. I can show it what it looks like.
Also, it might be on my end, but your video and audio are kind of getting a little choppy. I don't know if that happened to you, Dylan, as well.
Yeah, Chris's voice was a little choppy.
Yeah, I can hear it too. Yeah, it's my stupid video card. Oh, you know what? I know what it is. I will be right back. Please give me 1 second.
And with that, I'm out. The demo crashed, so see you later. Well, cool. Well, that sounds like a very cool hack project, but now we're on the edge of our seats waiting. For the AI inference part of what you're doing, what platform are you using for that?
I'm not sure yet. I was still in the research mode. I was looking at Amazon's offerings with like SageMaker and that sort of thing. But if you have any ideas, let me know.
Yeah, I don't know specifically for like image detection kind of stuff. I've mostly done the for the hack project I'm working on, we're using the OpenAI APIs for the speech to text and then just like general language queries. I don't think they have anything with image recognition, but
I I'll report back maybe next live stream and see what I land on. But last hackathon, I was doing some edge AI processing on device to do bird detection, and I used Edge Impulse to help me develop a model using TensorFlow Lite. And the problem I was running into there is I had to make the model really, really tiny and fitting it on a microcontroller. There wasn't a whole lot I could do. So this time I wanted to try doing that in like sort of like a post upload scenario and just process every image that comes through the pipe and see what I can do with pipelines.
Nice. That sounds cool. How large are the images?
I will tell you. It looks like the last one I sent up was about 25 kilobytes.
Oh, nice. So pretty small.
Yeah.
Right. But they're color images though?
Yep. The
Nice.
ArduCam has it's a 5 megapixel camera, and it has a lot of different settings you can set in the firmware to adjust size, resolution, color, that sort of thing.
Oh, that's cool. Nice. Well, I want to hold out until Chris gets here so we can finish talking about our demos. Well, I'll talk about what I'm working on here because I'm collaborating with Chris and also Jonathan for Dylan. I know I'm fairly certain we've talked about the Humane AI pen before.
Mhm.
You're familiar? Okay. So lots of things that it is doing could flow through a platform like Goliath. Obviously, I'm pretty sure they have like Snapdragon processors in there or something. So, it's like a not a microcontroller. But we wanted to see what we could do with a microcontroller talking to Goliath and using a variety of pipeline-esque features to talk to OpenAI. And so Chris actually printed this case here. Oop, I'm over here. That
Ooh,
is
I want one of those.
yeah, they're very cool. Wait, do you have a 3D printer? Because you could just print it, I guess, yourself if you wanted
I
to.
don't have a 3D printer. I have two.
But yeah, so it just like opens up and try to show the depth here a little bit. So it's pretty small in there. And there's a few different kind of like modules that we were looking at for this. We ended up getting this M5 stack Core S3, which is kind of their newest module. Weren't you doing something with M5 stack at some point?
Yeah, I have the M5 stack Core 2, but it
Nice.
turns out they have 3 different variants of this exact device because there's supply chain issues with the screen. And the one that I happen to get, the screen is not currently supported in Zephyr. So if I feel like learning how to write device drivers, I could potentially get it to work.
Yeah. Well, that's what I've ended up doing because so this has the unlike the 2, this has the ESP32 S3 in it, which has great support in Zephyr. Unfortunately, well, actually, and the display also has support in Zephyr, so that's great. What we're mostly looking at the moment to get focus is using the microphone and speaker on it. And the ADC chip that's in here does not have support in Zephyr. It's not like too complicated to implement though, so I'm just about done with it. But I am spending a lot of time just writing drivers at this point, and the DAC for using the speaker as well is also not supported. So it's turned into a heavy firmware project. But in theory, once we get the audio samples off the device, then it should be pretty quick going from there. But it's a pretty capable little module. I know you were playing around with it, Chris. I just went through and showed off your case too.
Great. Yeah, I saw that. Yep.
Yeah. Okay. Cool.
That's Jonathan's design. I am just the printer. I'm not the designer.
Oh, okay. I wasn't sure if you had modded it or not, but okay, cool.
No.
Yeah.
I'm just the local printing facility.
Does that fit on your M5 device, or was that printed
Chris
for a
is
different
working on that side.
It fits in the envelope. Mine is currently in pieces to try and. It's actually an interesting stack up too. That M5. I actually wanted to use some of this for other projects because this is actually meant as an industrial. It's got a DIN rail mount on the back here. Yeah, so like Dan shows us in 2 pieces, and yeah, it's a really cool design. It's low cost. It's got everything on it. Unfortunately, the only thing that I found out about it that I don't like so far, and I think it's workable, we can work around it, is that all of the charging infrastructure is on Dan's right hand there on the left side if you're looking at the screen. And that's got battery charging. It's got a 9 to 24 volt input. It's really meant as an industrial input kind of thing. And so you could also wire to that. And yeah, so basically you have to have them plugged together though in order for the screen to turn on. So I think that's probably just like a 5 volts being available on the thing, even though there's 5, the USB is on the device. So, but even just the default boot up is pretty cool. So lots of things to play with that.
Is that just for the screen, Chris, or I haven't tried it with it separated. Does nothing work without them connected?
The screen was the only thing that I was really checking at that time. So.
Yeah, cool. I'd assume that probably the other stuff doesn't work either, but we could look into it because
Looks
we
like-
technically
looks
don't
like
need
the
the stream.
designers in the chat right now. So there we go.
Ooh,
Yeah, I think we'll get there. All right. I can finally show I'm back. I think I'm not too choppy now.
oh, also I was gonna ask, did my mic get better?
It did. Yes.
Okay,
Much.
so yeah, StreamYard lies. Actually, I think it's my fault still, but it did say that it was using it. But if my default audio on the machine is not also it, then it
I see. Yeah.
it'll
Okay,
get you.
so
It'll
I
come
have
for you.
this box here, and so this is currently running. So this is the Aludel Elixir. This is a very large cell antenna with good gain on it, more than it needs to be, but also why not if you're not space constrained. It's got currently battery powered. And this thing is pumping data out to the cloud, and we can check that when I go and check my logs, and hopefully that'll work. That's the right screen. There we go. All right, so this is the project I'm on right now. We should hopefully see some logs coming through. Looks like we do. We can see that my cell coverage, even with this high gain antenna, is terrible in my current office. But what we're really seeing here is this thing is cranking out packets of data every 2 minutes currently. Yeah, because that is in the settings here. I have it set to 120 seconds. So every 120 seconds, it's just looking at the cell tower, and it's looking at the Wi-Fi SSIDs in my area. And then it is putting them in here. And this is actually the new view on LateDB Stream that Tron worked on that I love, that basically puts all the data in much more compact format. It's awesome. But you see there's a couple of things in here. So LTE, these are all the different towers, and then also MAC addresses here. And so I have a couple of output streams here. And Dylan mentioned having two kind of side-by-side destinations and pipelines set up. I actually really like this one because I actually have one going to a test webhook and the other going to a prod webhook. And that's super useful too, because I'd have to go back in and like type in the new address if I wanted to just use the test infrastructure of what I'm sending this to. So like that's another use case I hadn't even thought about, where it's like I can just switch in there and you get a lot more visibility when you're sending to the test webhook. Actually, I can let's just
You can send to both at the same time too.
You can send to both, right? Yeah, I didn't know what it would look like on the actual test side. But what we're sending to here is N8N. This is like what I mentioned. That's what Jonathan showcased in the live stream last week. And after that, he kind of nerd sniped me. And he's like, hey, there's a way to do local install of N8N. And I was like, oh, that he did it with just Docker on his local machine. I was like, yeah, but we could also do it on DigitalOcean. And so I just spun up one on DigitalOcean, and we now have n8n.goliath.dev, only available to Goliath employees. The rest of y'all should be so lucky. And so, yes. And so basically, if we go into so we can go test workflow, and you see it's just waiting here. And so because I'm sending to the test URL, it says it's waiting for me to send it. And because I have a trigger over here, let's see if this works. There it goes. Yeah. Wow. And it has a little animation too, which is super fun. And so what's happening is and if I click into each of these, you can see here's that test URL, which I probably should change now that I'm showing it on a live stream.
Is there no auth on this?
There is no auth on this currently. Be kind, people. Be kind. There will be auth right after. As soon as Dylan or Dan starts talking, there will be auth in here.
Right.
And it's all self-defined. You see all the data coming through here. And then I could switch over to the prod. I'm in the wrong window here. Prod one here as well. Either one is fine. And then if I go back, you can also pin. The other nice thing is that you can pin once you get a good data packet. So what I had been doing to start with is I had actually been doing using the simulator, and I just had a sim one here. So I sent through the test packet from here.com. And that worked great for troubleshooting all this stuff. So I was able to troubleshoot. Basically, I was able to send it through my sim device. I had it go through the pipeline. I could see that happening. and then send it to here. And then I saw it here, and I could then just pin it and not have to actually send it from the simulator anymore. I could just then start triggering this thing over and over again because now it's pinned. So I think if I hit play, yeah, it actually, that just tested that node, but now I can also test the next node, test the next node, test the next node. And so here, what I'm saying, this is what's actually, that packet that you saw is actually formatted to go to here.com. And, but the thing I wanted to implement, the thing that I wanted to implement is, at first I started actually pulling these things out, but then we started thinking like, well, if you had fewer than 2 or 3 access points, you'd want to be able to like make them more dynamic. And so the device is actually in control here. And that's really the key to this kind of setup generally, because which will become more apparent as I keep going here. So if I only send one LTE access point and only one Wi-Fi access point and no LTE info, it'll actually error because they don't want it so that someone could drive around and figure out where the cells were. Like I could drive past Dylan's house and know the MAC address that he has and find out where Dylan is by just getting closer and closer and closer and closer. That'd be extra creepy. This is a little creepy, but like, extra creepy. And so they don't let you do that. They basically increase the accuracy. The circle that's around your dot basically on a Google map.
Do they? Can you send 2 MAC addresses and that'll do fine?
I'm sending 10.
I know.
10.
I know, but if you sent 2
fine.
MAC addresses and no cell tower, would that work?
That would work. Yes.
Okay,
yeah.
Cool.
It's just when you get down to 1. Because
Gotcha.
they don't want you to be able to range on it. And what would and there's even a setting you can set on the Here API where you could say some special mode they have where they basically then this accuracy, they'll never give you an actual accuracy, right? So they don't want you to be able to do range finding with people's access points.
Gotcha. That's really cool.
Yeah. So, I mean, I guess you could kind of do it with just the RSSI, but still. So basically we're sending this out. And if you say you just sent an empty packet from the device, something wrong happened, you would then just get a 404 from as long as the API is set up correctly, it basically sends back a 404 that says, I don't have any data. Or if you go to go out into the countryside and you set up a bunch of new Wi-Fi access points that have never been seen before, it's going to be like, I've never seen these. I don't know what these access points are. I don't see any cell data. So it's just going to send back a 404. So you need to have some kind of handling for that. And so that's ultimately what this is here. Nope. Going back here. That's what this if is here. I just test on the status code. And so if the status code is less than 300, which means that it would be a success, then I pass it through. And if I do pass it through, this is the key point now. I send it back to LightDB state either way. But in the success side, now I go and republish that data back to the LightDB state node. And so if I go execute previous nodes, because I have that data there, test step, there we go. So now this is the data that gets pushed back into LightDB state. So this one says accuracy within 37 meters. So that would be like the size of the circle that you draw on the map around the area, because it's not precise. And then Latin long, and it's in my neighborhood, and then status 200, and all that stuff. Then if I go back to the device, I actually see all that stuff here. And people might be asking like, well, why would you do that? Why would you go and have that data back on your device? The reason is because I often have, of course, I can't find it now on my bench of crap. I often have this plugged in, and this is a Neo M9N U-Blocks modem. And when this is on, this is a costly battery-wise kind of operation to have GPS always running. But when it's on, I can get down to like meter accuracy. And so starting to do like sensor fusion, you could potentially get even better than that. But with GPS, I pretty much always wanted to default to GPS. And so the idea here is the reason I push it back to LightDB state and have the device know its kind of approximate Wi-Fi LTE location response is because I wanted to be able to decide if I have a GPS signal at any given time, I'm going to report that. If not, I'm going to go and report the Latin long from that has been calculated on here.com. Mm-hmm. And that is something where now say it's not the same kind of device, but say I had a screen on here as well. In theory, it would be a lot of overhead processing, but in theory, you could also have your Latin long displayed locally too. And you could have, a maps approximation. You could start to have that on screen on an embedded device, right? Obviously, all of our phones do that. There's a lot of processing, a lot of capabilities that go into that. But doing that on an embedded device is very non-trivial. And now having that lat and long back there really makes it useful. And I think the bigger case is actually for an embedded device would be the lower power nature of like wake up, scan the tower, scan my local Wi-Fi access points, get an approximate. It's like if I'm in the same kind of vicinity, I'm happy. And so that ultimately, so what I'll be doing with this the rest of today is republishing this over LightDB Stream, which seems kind of silly, but it's because the device is the source of truth. So thank you for coming to my TED Talk.
Well, that's really cool, though. So you can effectively choose to only turn on the GPS that's expensive in terms of battery power only when you need
and time too, right? So like the other thing is like when you start up there's something called cold start for a GPS, where like when this thing wakes up, even if it had pure, clear skies, I'm outside, I have everything I possibly need to do, best case scenario, it still takes time to acquire a lot of satellites because the amplifier is like, it's like GPS is amazing. You're pulling like minus 140 dB. It's like picovolts of signal coming to your device. And it's just amazing that it ever works at all, but it just takes time to do that. So again, from like a faster kind of version, this is what you see also when you boot up something like Google Maps, you'll often see like a approximate location, and it'll kind of, your circle will get smaller and smaller around you as it finds more and more accurate things. Of course, you also have a 5,000 milliamp hour battery on there, so a little column A, a little column B.
Yeah. Wow. This is very neat. It makes me think as well, like if we could move, like we could tighten the loop here, in terms of like, the really what the device cares about is whether it should be using GPS or not, right? And so like ideally, I guess in my mind, all we would communicate to it in like a perfect world is like use one or the other, right? Either be scanning for the Wi-Fi SSIDs or be using your GPS, and then in pipelines, for example, we would do all of this like let basically like send the proper data, right? So if we say, hey, turn on GPS, once we start getting GPS readings, like we'll just send that through the pipeline. If we get, an SSID, like imagine a pipeline that said like, okay, if you get an SSID or a list of SSIDs, then call here.com, supplement the data, and then pass it through. If you get GPS, just like pass it through. And that would be really neat.
And that would be pipelines being the source of truth. I feel like right now I'm at the device being source of truth, but I think it's important to just know kind of who's in charge. One of the things that was pointed out to me too is if you look at this list of data that's coming through currently, you could go back through and you could recalculate, and you could actually go and say, well, our mail carrier is walking the same route every single day. And I could start to just do differential and say, all right, I know I should see this stuff at this certain amount of time. You could start to just do pattern matching like that as well. Like basically the data set that ultimately lets you look up where you are also lets you to then go back, calculate, and say,
oh yeah,
you could formulate new data sets based on it. I don't know how. There's a lot of very smart people that have put this stuff together, like the APIs that we're accessing. That is basically how those were created though. Because at some point they were also correlated, where a phone, had a GPS signal and said, I have a GPS signal right now. What do I see? Oh, I see these 10 WLANs around. Put that into your database record. Do that enough times. You do some averaging. Well, not averaging. You do some wizardy Python magic math stuff. And then you start to be able to serve up this, stochastic data around where you might be.
So does here.com purchase that data from like cell carriers?
I have no idea.
Yeah. We can get a guest on.
Here's what I do
know.
Google also has an API that looks very similar. These are very expensive API access things because I think they spend a lot of money to make them, and they also want to have some competitive advantage. So it's not just like any old phone, any old Maps program could use this. But you can go and actually access the Google API in the same way if you wanted to. So you can put in LTE, put in LAN. It's wacky. It's really wacky.
Yeah. I was using some location stuff in the NRF SDK recently, and noticed they have like kind of a generic interface for this type of thing, where they have the NRF cloud implementation. They also have here.com implementation, but you could also just like add other ones as long as, you satisfy whatever's in the header files. But you made a good point that it, like, let's say you're using the NRF SDK and you want to, plug in here.com, you'd have to add an HTTP stack, right? You'd have to have separate credentials. You'd have to do all of that. And here we're just saying like, okay, you definitely need to communicate for like OTA updates and general device management stuff. Let's just use that same connection to talk to here.com, which I think is really cool.
Yeah, this is the use case I'm often pointing out when I've been calling Golioth kind of a thin, precise pipe often these days, because of like, if you're going over CoAP, you have Seaborn. I don't have Seaborn coding currently, but it's like very realistic that it could be. And you have basically this narrow channel down to a power and data constrained device. And, I don't want to have a secondary connection out to HTTP. I don't want to handle security out to that other endpoint. And so go through the same thin, precise pipe up to Golioth back and forth, and then have all the heavy duty cloud API stuff happen on the other end.
Absolutely. And go read my blog post from Thursday where we talk about that. Self-promotion. Well, that's really cool. That is I think that's a top hack day demo. Really? We'll see what you have on Tuesday also. Yeah. And I'm going to come by and pick it up and go for a run with that device next time. And you can tell me where I'm at.
Smaller antenna on it so that it's not, or we just duct tape this to your back.
Yeah.
The big antenna.
Or your hat.
Make it like a backpack.
Yeah. Well, I've got a running pack. We can just stick it down in there. It'll be perfect.
Perfect.
I was
might have to work on sweat
right. The IP whatever rating.
Yeah, IP65.
Yeah. The that it's last week when I was at a bike race that was kind of in a remote area. I was talking to Chris about this. I was trying to use the Thingy 91 to track my friend who was in this bike race where I needed to know basically when he was coming through different checkpoints. And the GPS, just using GPS alone on that device was untenable. So it's cool to see this type of thing, which could be used with, either something that doesn't have GPS at all or something that doesn't have a very good antenna on it.
Yeah, the Thingy 91 is one of my favorite platforms generally, but the GPS requires additional kind of starter. So we talked about that cold start kind of thing. Basically, a lot of times the solutions for the 9160's GPS is to kind of preload it using something called AGPS, assisted GPS, where you kind of say, here's a library of likely satellites in your area, and use that to kind of bootstrap up to finding more of the satellites, that sort of thing. So
nice.
Yep.
Cool. Do y'all have any other hack day stuff y'all want to talk about? Because I thought we could also jump into the pipelines launch, our new transformer, a couple of those sorts of things.
Transformer for sure. I am generally just trying out more N8N stuff. I think as a hardware person who never really did, like people just said, oh, like just talk to the API, whatever. Like Dan help unblock me on the here.com API. But like generally, I've used the REST API for Golioth a bunch. But like having something a little bit more visual, it could be N8N, it could be Node-RED, it could be Zapier or whatever it is, right? Like that really helps me quite a bit. And there's another one called Windmill that someone told me about on Mastodon. That's open source. All of those, though, like having that was an unlock for me personally.
Yeah, that's awesome. Cool. Well, maybe before we get into the new transformer that came out today, I was thinking we could just kind of like go back and walk through kind of like how we got to pipelines, maybe some of the process around launching it. I mentioned, so Dylan had a blog post last week for the pipelines launch that talked about kind of like why pipelines are beneficial for our customers and what types of customers are going to get benefits in terms of cost or data privacy and some of those sorts of things. And then I posted this week kind of like more on the technical side of things and how we went about launching it. But I was thinking, this is something that, Dylan, I feel like maybe at least 9 months ago, maybe longer, that this like kind of idea started to bounce around a number of our heads. I was just kind of like curious, maybe from your perspective, coming in, kind of like seeing the Goliath platform at that time, and thinking about maybe some of the things that we could improve upon or some of the things customers were asking for. What was kind of like in your mind the initial impetus for going in this direction, which eventually led to us like implementing these concrete components in our infrastructure?
Going back a long time, I've got to really
Yeah.
rack my brain. But
How many
one of
startup years
the
ago was it?
10 startup years, honestly.
Yeah.
But one of the first things I did joining Goliath was just build a little Hello World application on ESP32 that was collecting different atmospheric data, and then using all the features, including LightDB stream and our output streams. And one of the, I was immediately, I think the first thing I was doing is I was just like sending it to a webhook through output streams and then storing it in a MySQL database on whatever that hot planet scale DB at the time. And the first thing that I noticed is I had to build logic into my own service, my own backend to filter the data. Because our previous output streams, it was just like you set up an output stream in your project and all data just goes to the same endpoint, basically, which was great for some use cases, but more complex use cases when you're sending different types of data or like GPS data on one endpoint and atmospheric data in another endpoint, or in my current hack project here, the image ingestion, I'm sending images and then I am sending other information that's not related to those images. So having the ability to filter on paths was one thing. And then the idea of sending other types of data besides just JSON. Previously, all data, the data models, the data flow has kind of been inverted to how it was. Previously on Goliath, couple weeks ago and for forever before, you sent data to Goliath's application service that we call LightDB Stream, which is a time series database. So all the data went to there, and then the output stream was kind of like an after event. So you could optionally send data that went in the LightDB Stream out to output streams, which is limiting on the types of data that you could send. You could only basically send JSON or other incantations of JSON like CBOR. So with pipelines, we've now inverted that a little bit where all data flows to pipelines, and then you can choose optionally to send it to LightDB Stream and or other services, which really opened up this idea of arbitrary data ingestion we've been talking about for a long time. We're sending things like images or crash dumps or sensor readings, any kind of data. So that those sorts of things were a lot of the impetus. And I also just have had in my brain for a long time healthcare use cases coming from some of my previous roles, and removing the need to store all the data on Goliath unlocks a lot of stuff in and around that area.
Yeah, absolutely. I think those are some points that stick out to me as well. And to Chris's points earlier about having that one connection, like we can't really like make that claim or sell that as a feature of our platform if we allow you to send like a very restricted set of data. And I think it's one of the things I really love about working at Goliath is like even on this call, right? Like we all have pretty different backgrounds and skill sets. Although I feel like skill sets kind of like converge at Goliath. We all start to like get good at each other's things, which is super fun. But kind of like in that vein, Sam, our firmware lead, who's been on the stream before, like him coming into Goliath and being like, I'm never gonna send JSON data. Like what? Like what are you talking about? And obviously, you mentioned we supported CBOR and some things like that. But even so, like even if you're sending that kind of like semi-structured data, where pitching efficiency and then not really letting you like take advantage of it in some respects, and then if you want to send that other data, right, like we're saying you can't send it at all. So how can we really say that like we're only that one connection that you need to the cloud, which is something that we view as really valuable. So I think it's been cool to see like this kind of like one feature was actually like a very large platform shift that came in multiple layers, and opens a lot of different use cases by just like tearing away some of those constraints. I also like that. And I think existing users, I heard this from, I think maybe you, Chris, also the other Chris, who you were mentioning earlier, Chris Wilson, the taking the kind of like inherent properties of LightDB Stream, and even if you still want to send to LightDB Stream, being able to see what's happening. So I think some of those examples are our batch transformer, which splits a message into multiple different messages, our inject metadata transformer, which takes some information about the device and the project that's in and shoves it into the body, our include path or inject path transformer, which like uses the path to modify the nesting of the object in a JSON object. Those are all like visible to you. And in our migration path, we like just took those things where are already happening, kept the same behavior, so backwards compatibility, but made it clear to you and actually allowed you to go in and just like edit it and say like, oh, I actually don't want that to happen anymore. I don't use that feature, or like I want to add this, and I think that is something that I really appreciate about it from like a elegance standpoint from a technical perspective. So I think that was really neat as well.
Yeah, and I think I may spoiler alert here with what you're about to show, but we have a number of customers at Goliath who already have infrastructure set up and fleets of devices that then get modernized to use new chips and new RTOS and land on Goliath as a solution. And one thing that's been tricky in the past with our output streams is the ability to talk to many different kinds of webhook types of APIs. And I think pipelines with the addition of transformations and some of the functionality around there just opens up more and more REST API like type destinations, which weren't possible before. Like Chris playing with NAN so much. Now that the webhook destination and pipelines is so much more flexible, it just opens up a wide array of destinations too, not just types of data being sent.
Yeah, that's a really good point, because another thing I think we talk about Goliath as is like the place where cloud engineers and firmware engineers form their contract, right? How we're going to talk to each other, how our systems are going to interoperate. And one of the things that we like to preserve there is optionality for both parties. So the cloud team can come along and say, hey, as long as I honor this contract that I created with the firmware, I can do whatever I want on this side of the house. And firmware engineers can say, as long as I honor this contract I made with the cloud engineers, right? Like I can do whatever I want over here. We can change, we can evolve, we can improve. And if you need to change the structure of the data that the device is sending because you're using a new cloud backend or destination or something like that, then you've made a leaky abstraction, right? Where like the decisions of the cloud team are now like impacting the firmware team. And so I like that clean separation for sure. And like you said, we have some things right now that allow you to transform data, but I think we're going to continue to move to more and more capability to be able to say like, you can really do whatever you want here, which I think is very exciting. Well, maybe we'll since we're alluding heavily to it, we can go ahead and chat about our new transformer that we launched yesterday. And I think we'll maybe put out a blog post or something next week, but you see it here first on the Goliath Friday afternoon stream. So new transformer that came out. I'll pull it up here and I can share my screen. Although this is always a little dicey, as my Golioth colleagues know. For me, my machine likes to crash whenever I share my screen. So Linux with multiple monitors, gotta love it. All right, so in our docs here, at the launch of pipelines, new data routing section came through here. So the new transformer we have is JSON patch. I'm sure a number of folks are already familiar with JSON patch. It's essentially a DSL that's frequently used in HTTP patch requests to modify a resource on the server. So if you have an object on your server that is, let's say it's a project on Golioth or something like that, and you want to change the name of the project, or you want to, I don't know, remove an attribute of the project or something like that. It basically gives you a DSL in JSON to be able to modify JSON. So here are the operations that are supported. There's an RFC if folks want to go look through all of these. But basically, it's pretty simple operations where you point to a field in a JSON document and you say, perform this operation with it, optionally with this value, depending on what operation you're performing. So add, remove, replace, copy, move, and test. And test is one that's a little less known because it's frequently not utilized as much in HTTP patch requests, but it allows us to do some pretty interesting things. So we'll take a look at that. But here's a simple example of JSON patch being used in a pipeline. So we have this initial payload that comes in. This is the default in our simulator right now. And we perform a replace operation on the temp field and just overwrite the value. We perform an add operation for a new structure here, hello, which is going to take a value of an array of strings with one string world, and then a remove operation on the latitude field. And the result is, exactly what we said there. We get our new temp value, we add our hello, and we remove our latitude. So it allows you to do some pretty interesting things, especially when you start to utilize move, because you can do things like take your data payload, move it to a substructure, supplement it with other information, and that sort of thing. I know Jonathan, who is kind of our definitely our CEO, now also our chief pipelines officer, we like to joke, has been doing some really interesting things that I won't say here because I think he'd be a good one to have on and maybe a partner on the stream to talk about. But to kind of talk about how this works in practice, we also have a new example, and this is using that test operation. So a test operation in a JSON patch basically says, hey, evaluate this. If it's true, apply the patch. If not, abort the patch. So in this case, we're saying if the device ID equals this value, then apply this patch. So add this demo true. And otherwise don't do anything. And then we're including another step with a JSON patch transformer that will apply to everything. The interesting thing that we're doing here is the device ID is not typically in the payload, in the JSON payload that you would access via transformer, but we're using the inject metadata transformer as the first step. So we're basically saying nest our payload data, add device ID, project ID, and timestamp, and then we are modifying our payload data based on the presence of that metadata and the value of that metadata. And then we're actually stripping that metadata back out. So it's allowing us to do some like conditional operations. And we can go ahead and open this up and see it in action. I will use, I think, Pipelines Tester was the one I was testing this out in. So I'll do a conditional JSON patch. We're going to need to, actually, I think I already have this one in. Let's see.
Real quick, Dan, why would you want a pipeline like this that looks at the device ID and appends additional metadata conditionally?
Well, in this case, the reason why we're doing it is because we're imagining that we're like doing a demo with a device and we want to filter that out from our production data. Maybe another example would be like if you have a fleet of devices and you have like internal folks doing demos and you just want to make sure those are separated from, real customer data or something of that nature. That could be a good option as well. It looks like I actually did not have this pipeline, so this will work well. I'll actually create it this time. So we'll put it in pipelines tester, conditional JSON patch. I'm going to come back and change this device ID in a moment. And I'm going to turn off this one. And I'm going to create another device here. Chocolate like baboon. And we'll say for silver ratty fowl, we want to mark it as demo. And for the other device, we won't. So I'll save that again. We'll jump in here. So starting off with this device, I'm going to put the credentials in the simulator and jump over to LightDB Stream. And we'll turn it on to real time here. And what we should see is, because this device ID matches, that this data will come through, but we'll also have that demo tag appended. And if we look and see, the data does come through and we see demo true. And also all of that metadata that we injected has been pulled out. If we went and looked at the device where it doesn't match, we'll update the credentials here to be this device and put it on real time again and send it through. And when we see the data come through, we'll see it's just the data with no demo appended. And so we could go in and, continue to change this over time. For example, I think it's interesting sometimes to just keep the metadata in there, and we can see what that would have looked like. So I'll go grab this one again. And well, we'll go ahead and send it, and then I'll just refresh it when I jump over. All right, so it came through. This time you can see this is the data that was present when I actually decided whether to add the demo true or not, and I've just left it in there. But, depending on where you're sending it, you might want to pull that out to save bandwidth outgoing as well as your data destination. But yeah, so there's a lot of different things. This is also just one example here. Also kind of a contrived one. You probably don't want a separate rule for every device ID. But I think this opens up a lot of interesting use cases here. And I think that also meets my quota for a new pipeline every week. So
we're going to count it. We're going to count it. Yeah. Yeah. Let's go.
Actually, maybe multiple pipelines. I edited that one.
No. You only get credit for one.
We're going to have a pipelines ship of Theseus situation where if the pipeline that's left does not match any components of the one that you started with after editing, is it still the same pipeline or not?
That's a good question. Yeah.
Cool. Well, I also have a call to action for both of you and for all you listeners at home. If you would like a transformer, if perhaps you like to send protobuf data from your device, if perhaps you like to use some other DSL, not thinking of one at the moment, but there are many others out there, we can add that. So just drop us a line, put it in the comments, like and subscribe, of course.
The weirder, the better.
Right.
Exactly. Challenges.
Well, one of the things that I don't think this is exposing product roadmap too much, but one of the things that we will do is do some feature flagging of transformations. So we might have some opportunities to do some really wacky stuff for a subset of folks that are interested. So, ping us, let us know.
Could we append hot dog, not hot dog, to
an image?
To an image?
We could. So the tricky thing. So actually, I think one that would be interesting there, and a transformer maybe we should have, is accept binary data and base64 encode it into JSON. If you wanted to send it to something that just allowed JSON, like LightDB Stream or something like that, that could be an option. Then you could chain together base64 encode this image and then put hot dog or not hot dog in it using some AI model, and then I think profit comes after that. I'm pretty sure. So
That sounds right. Yeah.
yeah, that's how it's worked before. So cool. Well,
I want you all to know that I did turn on authorization, so nobody is getting into this webhook that I showed on screen.
This is the most secure webhook out there. Well, cool.
Don't mess with my test infrastructure, please. It's administered by me. It's I have. It's not. It would not be cool. Don't mess, please. Don't mess.
Don't take my droplet offline.
That's right.
Not my droplet. Cool. Well, I think we're gonna have to do another check-in next week on hack projects. Maybe bring along some other friends as well, because I saw some other stuff brewing that is quite exciting. What are y'all up to this weekend that you're willing to
Aside from
share?
hack projects, nothing, Dan. I'm just hacking all weekend.
You're not going to be bringing more boxes to my house?
Well,
Well, I'm not gonna be here, so if you bring them, they
Maybe
will
then
have
I
to
will.
sit outside until I get back, or that you can come
Okay.
on Sunday. But
Yeah. Or maybe I borrowed a key that you don't know about.
that's fine. Yeah, I'd trust you with a key to my house. I trust you too, Dylan, but you wouldn't be able to use it very much. Also, my house is very, very small. I'm sure much smaller.
We did just get a question in the
nice.
chat about pipelines, and if you could do the similar thing, a similar thing for downlink data.
Yes, not today, but not through pipelines, but you can do a similar thing for targeting devices. In fact, now I don't want to do it because I already self-promoted earlier. But in my blog post from Thursday, I can grab a link here as well, so that I'm not just talking into the ether. But in this blog post, towards the bottom, if it comes through in the chat there, there is some mention of not just how pipelines works, but how we were able to roll out pipelines actually a while ago internally using our device gateway that we implemented, which was kind of like the unseen part of implementing pipelines. And the device gateway itself is bidirectional, which opens up some interesting use cases. So if that is something that you would like to do, definitely let us know, because we are exploring that with customers today. So check out that blog post. There's some mentions about how that could work down at the bottom.
I don't know what downlink data actually means. Maybe John could explain it in the chat, but what is downlink data? Do you guys know what downlink data is?
Oh, I took it to mean cloud to device in this case.
So like the
well, John's still around.
The Here API, like in your demo, getting that data back onto the device effectively.
It is on the device.
Yeah, you can use LightDB Stream or LightDB State like Chris did.
Yeah, it's there right now.
It's an elegant solution for that.
The machine.
Yeah, cloud to device. John clarified cloud.
The Zoolander thing is.
Yeah.
Cloud to device. Yeah.
Yeah.
Great.
So I think also, an interesting thing as well is with pipelines, right? We allow that transformation. So can you do cloud to device with transformations in between?
Yes, that'd be the jam.
That would be the jam.
I think
Maybe
especially in terms of protobuf, right? So say you were sending up protobuf and then you wanted to have like super, like, or CBOR going back down, right? Sort of thing. No, it's not CBOR in the back end. So but the constrained nature, really clamping down that data on the back down of the device as well would also be a great thing for the future.
Yeah. In fact, that's actually how we work internally. So all of our services are JSON, well, not all of them, but they're JSON HTTP or gRPC or, that sort of thing. Obviously, we don't talk to the devices over that protocol, but all of the services that we implement, just for ease of use and being able to make them more portable and that sort of thing, are implemented that way, and we just translate them on the fly. So definitely a capability there. Cool. Dylan, what are you up to this weekend?
Unfortunately / fortunately, not hacking. I would like more time for my hack project, but most of these.
I used to live in Chicago. You only get 12 weeks of Chicago summer. You better be taking the heck out of the advantage of that. So
We'll be
hopefully
taking some advantage. Most of these plants are leaving my office and going into my wife's plant store that's opening soon. So we're going to be driving around, moving stuff into the store, getting some shelves from IKEA, moving them to the store. And then going
Dylan's going to Schaumburg.
Yes, indeed.
That is
and
where
then
the
going
IKEA
to
is.
a big supplier for rare and exotic plants and filling up a truck and bringing them also to the store.
Look at this guy. Another northerner. No Mike Stish. We here in the South, we enjoy a little bit more than 3 months.
Yeah, I will say I almost posted this morning, but I went outside this morning I had to run in the morning because things, and it was 70 degrees outside, and I stepped outside and I thought, wow, it's cold today. And then I took a long, hard look in the mirror and thought, you know, what has happened to me? This is disgraceful.
Go north, young man. Yeah.
I will not go north. I love the heat. I mean, right now, the humidity here in North Carolina is, I mean, you can just look out the window and start sweating.
Like a warm hug.
It is. It's like you're you get a drink of water with every breath, you know? So
I'm so well hydrated.
Yeah. Although
look at
Dylan
this skin.
also,
You know, get this. Wait, let me turn on the
it's not the cameras, it's the humidity.
Yeah. Look at this skin now that I turned on the touch up my appearance setting in StreamYard.
That really delayed your video too when it
Oh yeah. Yeah.
It's like, we're doing a lot of work here, so
that's right. This is not a young man.
Although Dylan gets the worst of both worlds, I feel like, because you've got the humidity up there and it's pretty humid in Chicago, right?
And then I also have a humidifier blowing on these plants.
Yeah. Dylan really loves humidity.
Yeah. Oh, wow. Look at this.
We'd be able to get in thunderstorms like every week. So
oh my gosh.
Definitely humid here.
Yes.
9 degrees? Oh wow.
Well, 9 Celsius. So.
Oh, true. But still, yeah. I don't know. Whenever I talk to Tron, I now follow Tron on Strava. I also follow Chris on Strava, but Chris, where are those activities, my man?
I don't know. I think my activity tracker's broken.
Yeah. Well, good thing that you just built a new one. So
good thing. Yeah.
Wait,
now is when all of my
pipeline to Strava is going to be our demo next week. Unfortunately, you have to accumulate. You can't just stream to Strava, but you might be able to do something with Garmin. But anyway, yes, Tron is out there in the cold getting his runs in. So shout out to him.
Yep.
Yeah. Cool. All right. Well, we won't keep people around any longer. They have things to do. None more important than this, of course.
Showed up. This is, I think, our best attended stream so far. So
I know. What do you think it is? Do you think it was the cover art?
They saw the word party in the title.
Right.
Next
so
week, plant party.
Yeah.
After that, Garmin party.
Yeah. Exactly. We've just solved SEO. Cool. All right. Well, thank you all for jumping on. Thanks to all the commenters and watchers, and we'll be back next week.
All right.
Cool. See you, folks.
See ya.
All right.